Let's talk about space plants. Okay, so I've always been interested in plants. I live in a really arid environment, and I got kind of interested in space when I first read this book. It's called The Martian by Andy Weir. Most of you know the book or have seen the movie. It's a pretty amazing movie. And I think that it really resonated with me because the idea of terraforming the planet or growing crops on alien soil that is void of organic material kind of speaks to living in the desert, right? Obviously, I don't live on Mars, but it is an interesting thought experiment thinking about how similar it would be growing plants in the desert to how it would be growing things on another planet. So when I went to the university, I started learning about dendrochronology. And we're going to talk about that a little bit. But it's fascinating, the effects of what's happening in our solar system on how life thrives on our planet. And it's a really fascinating topic. And I read some really cool books. There's this one, it's called Exodus to Arthur. If you get interested in dendrochronology, that one has got some really interesting things about historical premonitions and how it might actually have been different volcanoes or meteor strikes, things like that. So that's a real kind of cool but bizarre book. And most recently, because I was interested in The Martian, I read Project Hail Mary, which also very cool book, although I have specific feelings about how the book ends, but no spoilers will be perpetrated by me. So let's talk about where this space and plant intersection is. Okay, so stick with me. We're going to start in 1877. An astronomer named Giovanni Schiaparelli starts observing Mars, and he sees what he thinks are possibly canals on the surface of the planet. And so some of you may have heard that Schiaparelli before. The Schiaparelli crater is a big crater on Mars. And so he, called them canals, but he wasn't convinced that they were man-made or alien-made. He thought they might be the result of natural processes, but as the shadows shifted, they weren't sure. They thought maybe crops were getting irrigated. Anyway, 20 years later, Percival Lowell is working at the Lowell Observatory in Flagstaff, Arizona. And he is absolutely convinced that these canals on Mars are made by aliens. And he wants to verify this. So he hires a guy named Andrew Ellicott Douglas. And Douglas is an astronomer, and he hires him to verify that these canals are man-made. Douglas goes to work. He works for him for, I think less than 10 years. And he observes Mars at night through the Lowell Observatory and realizes that it's a combination of optical illusions, and shadows, and bad optics, because this is obviously like 150 years ago. Telescopes are much better now. And he realizes that it's not canals, that it's just shit telescopes, and that's what it is. And so he brings this information to Lowell, and Lowell fires him because he doesn't verify his theory. He doesn't agree with him, so Lowell says, beat it, which is kind of a dick move, especially in science, but it is what it is. I mean, and it's worth mentioning that Lowell did predict that there were planets beyond Neptune, RIP Pluto, but still, that doesn't make you correct all the time. I mean, in science, you have to be okay with being wrong, and that's part of science. Science is self-correcting. Don't think science is fake. Science can correct itself. If it goes back and corrects itself, that means the science is stronger. Remember that. It's important. Okay, so what does Douglas do? He gets a job at the University of Arizona. Bear down. and he wants to teach physics and astronomy. And so he comes down here, and at this time, the University of Arizona is itty bitty. This is 102 years ago, so Tucson's a fraction of the size. And there is a wealthy widow out of Oracle, Arizona, who donates a ton of money to Douglas to build the Stewart Observatory. And the Stewart Observatory now is kind of right in the middle of the U of A campus. But when you look at historical photos, it's always so fun to look at historical photos. It's kind of on the outskirts of the university. And it's really amazing how time changes things. So Douglas gets the money, observatory gets built, and he wants to study sunspots, like dark spots on the sun. There's solar flares, there's intense magnetic fields around the sun, and that's what he wants to study. But specifically, he wants to study the effects of these sunspots on the climate and weather on Earth, because this is where we get like Aurora Borealis, right? The magnetic field, plumes come off of the sun, they interact with our atmosphere, cause beautiful colors, and sometimes they're in the far northern latitudes, and sometimes they come down to continental United States. But he wants to look at this, and he wants to see historically what this effect has been. But as he's a pioneer in this field, it hasn't been done, so he doesn't have a historical record of how these sunspots have been interacting with the planet, because he has a theory that there's an 11-year cycle of these solar storms, right? So kind of like how we have our seasonal weather patterns, like with El Nino and La Nina. He thinks these solar storms are occurring at 11-year cycles, and therefore the climate and the weather are changing in an 11-year cycle. And he wants to prove that, but how do you prove that, right? As most geniuses do, if you can't prove it with the conventional wisdom of your day, you invent a new field of scientific study. And that's exactly what Douglas did. So what he realized was, and something most of us know, is that tree rings, a tree puts on a ring every year based on its growth cycle, right? So every year the tree puts on a new cycle, and you've seen these things where you can count how many years the tree was alive. If you know the year the tree was cut down, you can count back and know what year the tree was planted. And they pay attention to the intensity of the sun because, photosynthesis, that's how they survive. And so particularly wet and sunny years, the tree rings, the growth ring may be wider than in years where there's less rain, where it's not going to be actively growing as fast as in wet years. And so he realized that the same trees, so we'll say pines, pinyon pines was his favorite tree to look at. If you know what year it was cut down, you know how old the tree was, say it's 100 years old. If you found a tree that overlapped, that got cut down 50 years ago, those tree rings would align perfectly with the first tree. And based on this, you could take section after section after section and start making a chronology going back in time, seeing how solar activity was playing into how these trees were growing. And he was kind of in this really sweet spot because we live in a really arid environment. And so we have many Native American ruins. We have cliff dwellings, we have villages in the middle of the desert. There's a ton all around the Sonoran Desert. And being in an arid environment, things don't rot in the same way. And I mean, I say the same way, they don't hardly rot at all. And he went to a bunch of these archaeological sites, found the same building material, so the same yellow or pinyon pines, and started taking core samples of them. So he'd just drill like a dowel out of the wood, and he could compare the rings along that dowel, building a chronology back 1,000 years. And he could see, based on those rings, as he lined all the rings up, that there was indeed an 11-year cycle. There's an asterisk there, if you know, you know. But it was kind of an amazing thing that he created an entire field of study at the University of Arizona based on plants growing on our planet, telling us information about weather, solar storms, on the sun, which is fascinating to me. So it's really interesting that he discovered that solar storms are going to have variation on our weather. And we do have variations in our climate. Now, this is not the same as climate change. Climate change is a whole different anthropogenic ball of wax that we're not going to get into here. But enter the book Project Hail Mary. And again, I don't want to spoil anything if you haven't read it or if you're looking forward to seeing the movie, but it kind of turns a lot of what we see as far as the sun and the interaction on our planet and biological processes flipped on its head, and how humanity responds to that and understands it. And it's a really cool book. There's a lot of really human moments in it, but the science is solid, fantastic. Andy Weir does an amazing job when it comes to the science. But it really inspired me to kind of make an art project. And so I'm a shoe guy. And I have a lot of shoes, but not the kind of shoes where it's like put them in a plastic box and look at them forever. I want to wear them. If you have something, wear it out, enjoy it. Don't put it in a box. It's not what it's meant for. Simultaneously to reading this book, I started getting fed a bunch of really strange videos on YouTube with people embroidering flowers, and it looked kind of fun. So I bought an embroidery kit. And I said, I'm going to learn how to embroider this week. And I did. And I got this idea to make a pair of Project Hail Mary Converse. And so this is what I did.
So I just wanted to talk a little bit about the different elements I'm going to put on these shoes. I wanted to start with the sun, obviously. And I thought it was really interesting that the sun is actually not solid. It's mostly made of gas, and it's hydrogen and helium, and it also isn't yellow, but it's white. It only looks yellow because of our atmosphere. So next I'm going to start working on the constellation Cetus. And Cetus is very important, specifically Tau Ceti. It is 11.9 light years away from Earth, and the constellation it's like a whale or a sea monster. And the myth is it was sent by Poseidon to eat Andromeda because Cassiopeia, her mom, was basically talking shit about Poseidon's sea nymphs. And of course, if you're doing a Project Hail Mary pair of shoes, you can't forget a betrothal line somewhere. This is the only part of this project that didn't come directly from the book. I found this image of a mission patch online, and I don't recall anything in the book about a mission patch, but I thought it looked really neat, so I wanted to include it. I'm not as happy with the way it came out, but I still think it looks pretty cool. So I did dedicate one side of one shoe to a guy named Gerard Kuiper. He also has strong U of A ties, but he discovered the moon Miranda around Uranus and also discovered like carbon dioxide on Mars and stuff. He was like the father of modern astronomy.
If you've made it this far into the video, I truly appreciate you. I hope that you learned something interesting. I hope that you think the shoes are cool. They kind of look like something Miss Frizzle would wear from the Magic School Bus, which is a very dated reference. But I appreciate your time, and get out there and plant something.